Assalamualaikum and hi all. Okay, so now we have done on chapter 1 part 2. So now we move to the chapter 1 part 1. Now we go to the chapter 2 part 2. So in this topic we will focus on the application. Okay, so on the previous video I already shared with you how can we deal with or how can we differentiate the multivariable function. Okay, so I hope that by now you know how to differentiate functions of two variables. Okay, now we want to look at some of the application of the partial derivatives. Okay, so the first application that we want to focus today is about increment and total differential. Okay, so firstly, now what can you understand with the word of increment? So okay, some students told me that increment of salary, okay, or something decrement. Okay, I would say that the increment is something changes, okay, changes of the input value. For example, you have the equation where your equation is let's say we have two variable function. So your equation is, let's say, x squared plus y squared. So you want to investigate what is the changes of the z if you change a bit the value, you put some changes on x. So what is the effect of z? And similarly, you want to know what is the effect of the z or the output if we change a very small there is a very small changes of y. So that is called increment. And then what is the total differential here? Total differential is the formula how can you solve this problem, okay, which means that you want to investigate the increment or the changes of z if we change very small, you put a very small x or very small y. Okay, so the rest we will look after that. So we want to look at the increment and using the total differential. Okay, so the formula, the idea is if you are given two variable function, if x increases, you change x, you increase the x. So for example, x from 1 to 1.01. So x is changed from 1 to 1.01. So your changes is 0.01. So normally for increment, we deal with a very small number, very small changes. Okay. Okay, so x is increases by, we put delta x, and then y increases by delta y. So the increases of x we call delta x, the increases of y we call delta y. And then the changes by after we put the changes in the equation, in the function of the variable, so z also can be changed, right? So the change of the z we call that as delta z. So in this case, the actual increment, we call that as actual increment, which is given by delta z, is so logically using the we put, let's say, okay, let's say you are given f is xy. Okay, now your xy, your point is changes from 1 to 1.01 and 1.01. Okay, so now how can you compute the changes of the function or the z? So what you have to do is, without using total differential, remember total differential is the method, okay? But without using total differential, what you are doing is you compute the z, which is the this is called old, okay, and this is the new. This one is called new after you change. So the formula is how can you change the exact, okay, or the exact changes or actual. Okay, the delta z is called exact changes, or we have actual increment. Okay, so the exact change, exact changes, also namely as the true changes, also we can determine call as actual changes or increment or actual changes. Okay, so that is about the term. So what always we do without using the specific formula, you just put the new value of x and y. So your new value is 1.01, 1.01, and then you evaluate the value using whatever function that you have here, and then minus of the value of the z using the old value of x and y. Okay, and then when you compute that, then you will get the value. For example here, so by using the new value of x and y, we put into the function. So you have 1.01 multiplied by 1.01. How can we know that? So this one is x multiplied by y, by using the given expression here, and then minus. So you put x equal to 1, the old one, and put y equal to 1 into the function here. Is the answer is 1. So when you compute that, so what you can have, so 1.01, sorry, 1.01 multiplied by 1.01 will give you 1.0201 minus 1, and your changes, your true changes is 0.0201. So this is called true changes without using total differential. Okay, which is total differential can approximate the changes of the z, just approximate, hampir, okay, penghampiran. Okay, so this one using the old style without using total differential. Okay, so what is the formula then? So in order for us to know the formula, we use the definition of differentiation. So we know that from the previous notes that I gave you, the definition of partial derivative with respect to x is you just look at here, you have the changes of x only, right? And then divided by dx. Dx is the differential, the difference or the changes of x. And then for partial derivative f respect to y, you can just put the changes of y. We have delta y divided by delta y. So this is from definition. And you have to note that delta here is also delta, denoted by delta. Okay, so from this definition, we modify, which is we just bring the denominator here to the other side. Then you can have dx multiplied by fx, which is this one. Okay, and similarly, for the fy here, we just bring the dy. Okay, so that is from the definition. So if we take the delta z is coming from the difference of the value of f when you put the changes of x plus the value of the z when you change only the y, this one. So then what we can have here, this one, which means that, so this, the first bracket is taken from this one, which is this is fx delta x, this one, plus, and this one is from the definition just now, and this one can be approximated by fy delta y. Okay, so this is delta z is the true change. So now if the delta x and the delta y is very, very small, then the increment of the delta x is denoted by dx. Okay, so if delta x is very small and also delta y is very small, so we assume that delta x becomes dx while delta y becomes dy. So delta z becomes dz. So from delta to be d, so we call that as a differential of z. Okay, so dz here is called as, so dz here is called differential of z, not exact changes of that z, but we assume if the changes of x and y, they are very, very small, now we can have dz, not delta z, where we assume that the true change, delta z is the true change, right? The true change can be approximated by the dz, which is differential of z. Okay, so differential of z is called total differential. What I want to say here, the true change here, the true change of z can be approximated by the total differential of z. So what is the formula of dz? So the formula of dz you can obtain from this one, which is you just change the delta to be dz. Dz is equal to fx dx plus fy dy. Or it can be shown here. Okay, so this called, so dz, originally we have dz, right? So dz is called true change, but now your true change can be approximated by dz, where what is the formula? So the formula of dz on the right side is called total differential. Okay, which means that I want to say that if you want to solve the problem related to the changes, related to the increment, the formula that you can use is using total differential. So if you are given the function z in terms of xy, so the formula to get the true change of z, so the true change of z can be approximated by the dz. So what is the formula of dz? So the formula of dz is fx dx plus fy dy. Okay, this is for two variable function because there is x and y. But if you have three variable function, w is the function of x, y, z. You got three variables now. So how can you obtain the true change of w? So the true change of w can be approximated by the total differential of w. So dw. So what is the formula? So the formula is wx dx plus wy dy plus wz dz. So this one is called total differential. And also that is for three variable function. So for two variable function, so this is also called as total differential of two variable function. So that is the idea. So meaning that if the question is related about the increment, the changes, the increasing, the decreasing, then this is the formula that you have to use. Okay, whether it is two variable function or three variable function. So in this case, where is your partial derivative? So your partial derivative is this one, and also this one. So dx, dy, and also dz is the changes of that particular variable. Okay, so next I want to show you the example. How can you differentiate between the approximate changes and the true change of the z? I mean, how can you apply the formula of total differential? Okay, look at the example one here. So you are given a function of two variable. Then you can see that your xy, your point, your input value here, change from 1 to 1.01, 1.98. Okay, so meaning that, okay, so now your function is given by 2x squared y plus y cubed. So your information given, your xy, your point, your input value, which is x and y, is changing from the point of 1 to 1.01, 1. Okay, so I would say this one is old value and this one is a new value. Okay, so now because from the formula, okay, look at the question first. Find the approximate. So there is a word approximate. Find the approximate change, meaning that you want to find the changes of delta z. That is the true change. As we know that the true change of z can be approximated by dz. So now we want to approximate. So if we want to approximate the changes of z, the formula that applicable here is called total differential. So the formula that you have to use is, so now we are talking about two variable functions. So we have zx or fx or zx dx plus zy dy, or you can also use a fx dx plus fy dy. As I mentioned before, z or f can be both, okay, because z is the function, so you can use z or you can use f. Okay, so now what is the thing that you have to have in order for you to get the answer here? So you have to obtain the partial derivatives of the given function respect to x, respect to y. As you can see here, you have to find the fx, you have to find the fy, and then you need to know as well the dx and dy. So what are they? So dx, dy is the changes of x and the changes of y. So how can you know that? Okay, look at your information here. Your information here told you that, look at the changes of x. So this is x and this is x. So x is changing from 1 to 1.01, which means that increase, right? So your x increases from 1 to 1.01, menaik. How can you know that? You can see the value here becomes larger. So meaning that we are talking about the changes of x. You have to put the positive because it is increasing. So how can you evaluate the changes? So the new one minus the old one. New one minus the old one. So you will get positive 0.0. Or you can also just consider 0.01. It is understood it is a positive. Okay, now look at the changes of y. So y change from 2 to 1.98. Do you think it is increasing? Or do you think it is decreasing? It's become larger, it's become smaller? So it is become smaller, right? But how small it is? Because this is decreasing, so you have to put minus. Decreasing means, in terms of mathematics, it is negative. Okay? So how can you evaluate the changes? So the new one minus the old one. So it will give you negative 0.02. So 0.02. Okay? Because how can we get negative? Because when you subtract the new one and the old one, and you will get negative value, right? So that's why you got negative. So that is the changes. So now what you have to do is by using the total differential. So your dz now is, what is fx? So you have to differentiate your function with respect to x. So now you have two terms here. So the first term, your x is 2x squared. You have x squared here, and the rest are constant. So when you differentiate x squared, you will get 2x. So you got 4x y, and then plus you differentiate y cubed respect to x, and y is constant. So this one is, they are all constant. So this becomes 0. And then we go to the partial derivatives with respect to y. So the first term, we have only y here. So the rest here constant. So differentiate y with respect to y, this becomes 1. So you have 2x squared plus, okay, you have to differentiate y cubed. So you will get 3y squared. And then you put into the formula fx. Fx just now give you fx 4xy multiplied by dx. So dx is now 0.01 plus fy is just now we got 2x squared. 2x squared plus 3y squared. Delta y is negative 0.02. You have to put more for increment, positive and negative is very important. Then you have to put the sign. Okay, if there is a negative, then you have to put the negative sign. And then now it's time for us to evaluate. Okay, so for xy, there is x and y. Also here you have x and y. So the question here, since you got two values of x and y, the old and the new, so which point that you have to use? So this is very important notes. You have to use the old one, the original one, because your changes already defined in your dx and your dy. You remember, I repeat, when you want to evaluate x and y into your dz, you have to use the original one, which is 1, 2. Okay, so 4, so x is 1, y is 2, multiplied by 0.01, and you have negative 0.02, multiplied by 2, 1 squared, plus 3, 2 squared. Okay, then you evaluate, use your calculator. Okay, so when you evaluate, so finally you will get negative 0.2. So if the question didn't mention that how many decimal places that you have to leave, so it is up to you. But let's say they ask you to leave your answer in 2 decimal places, then you have to put this one. Okay, so this is approximate using total differential. So look at the question B, actual, meaning that you have to provide this one. So how can you obtain the actual? So this, remember this one, this is approximate using total differential. So how can you obtain the true change? So the true change, as I provided in the previous example, you have to substitute the value into the function subtracted by the value of f using the original value. Okay, so we will compute the true change here. So now your true change is the f when the new one is at 1.01, 1.98 minus the f at 1, 2. So we substitute the value, which is, we have 2 and then x is 1.01 square, y, so 1.98 minus your old value of x and y. So 2x squared y. 2x squared y. Okay, I forgot to put the 2x squared y plus y cubed, 1.98 cubed. So that is from the new value of x and y minus the value of the function z using the old value of x and y. So you have 1 squared y plus y cubed. Okay, so if you evaluate that, okay, so when you evaluate that using the true change without using total differential, so you will get negative, if this one in 4 decimal places, so you have negative 0.1980. Okay, it looks different. So now we want to compare. So compare this one. Okay, if you leave your answer in 1 decimal places, so this one become negative 0.2 and this one become negative 0.2. So that's what I told you. The true change can be approximated by the total differential. Okay, which means that you can see that in 1 decimal places, they will have the same value. Okay, so as I mentioned, this one, total differential is just approximate value. Okay, so in exam, normally they will ask you to use this one because you want to apply the partial derivatives into your problem. But if you look at by using this formula, this is no formula at all, just a step. This one without using partial derivatives. So please make sure in exam you show me this step. Okay. Unless they say that find the true change. Okay. But if they say that determine the approximate changes of the z or so on, so we know that this one should be using the total differential.